Disseminate, the computer science research podcast.
Hello and welcome to Disseminate, the computer science research podcast. As usual, I'm your host, Jack Waudby. I'd like to start out with a little bit of an apology today. I'm not in my usual setup, so if the audio is not fantastic, I can only apologise. It does seem a bit echoey, but hopefully it comes across as okay. But anyway, we'll crack on. So yeah, Disseminate, this is a podcast where we interview computer science researchers about their latest work. We dig into the problems they've tackled and how they've solved those problems and how those findings that they've got from that research can then be applied in practice. The overall goal here is to sort of try and further narrow that gap between research and practice and make computer science research more accessible. So yeah, if you're an industry practitioner, researcher, or student, then this is the podcast for you. You can listen to us on Apple, Spotify, and you can watch on YouTube. So yeah, if you do enjoy the show, please like, follow, subscribe, and tell a friend about us. So yeah, on to today's show. And today we're going to be talking with Xiangyao Yu, who is an assistant professor in the database group at the University of Wisconsin-Madison. And Xiangyao's research focuses in three areas. That is cloud-native databases, new hardware for databases, and core database techniques. And we're going to be focusing probably primarily today on the first of those, and that's specifically disaggregation, which is the separation of database components into independently managed, scalable, and services. So yeah, Xiangyao was awarded the 2025 VLDB Early Career Research Contribution Award for his work on this topic. So I'm really excited to have him on the podcast today. Welcome to the show, Xiangyao.
Yeah, thank you.
Cool.
Thank you for the great introduction.
Oh, yes, okay. Cool. So let's get stuck in with some background then, sort of set the scene for the listener. And for those who are maybe new to the topic of disaggregation, can you explain to us what that means and how it differs from the traditional classic database architecture?
Yeah, for sure. So the classic database architecture, like maybe the most famous one is share nothing. And the share nothing is like they have multiple servers connected by network, but within each server they have computation, they have the storage, have logging, like all the functionalities. They kind of replicated that across different servers. But this is your one cluster. So disaggregation is like this different approach where they put different database components into different clusters. So now you have multiple clusters, right? And different clusters focus on maybe one cluster focus on computation, the other cluster focus on storage. So in short, you can think of this as conventional architecture is a tightly coupled single cluster, but disaggregation is a loosely coupled multiple clusters.
Nice, cool. Yeah, it's a great description of that and this stuff that we're decomposing all these different database functions into their own services. Cool. So yeah, I guess what motivated you to sort of explore disaggregation as this sort of shift in database architectures?
That's a great question. So I guess it started when I was a postdoc in 2018 at MIT. At that time, people don't really use the word disaggregation yet, so people call it different names. But it was pretty clear to me that this architecture has great potential, and it seems to me, seems to be the future. The separating the functionalities. So I guess that was a vague thought. I think, okay, this is still not certain, but I wanna explore this. I started with the first project, like a computation pushdown for analytical processing, and went from there, expanded to many other projects.
Nice, cool. Yeah, you definitely had some great foresight there because where things are going, you've definitely been kind of ahead of the curve there, I think, so cool. Let's talk about the shift a little bit more then. So we spoke about the traditional architecture a second ago, but what are the limitations of that architecture that disaggregation like directly addresses? And I guess this is we kind of need to start speaking about the cloud and the cloud environments, and then how did that sort of make this architectural shift kind of inevitable, I guess?
So you're totally right. It has to be the discussion has to be about cloud, because in the traditional environment, the traditional architecture was fine. For on-premises environment, for example, share nothing was a great architecture. It's actually perfect. But when we go to the cloud, the environment is different. It's not on-premises anymore. And in particular, cloud has this very salient feature called on-demand scalability. So which is, if you ask for more computation resources, you can get it immediately. You can shrink computation resources, and you only need to pay for what you use. And this kind of elasticity or on-demand scalability did not exist in share nothing architecture, or did not exist in on-premises environment. Okay, so it's more like, okay, when we move to the cloud, we really want our database to also have on-demand scalability, like it's super cool, super cost efficient. But because Share Nothing was not designed for this environment, it cannot fully exploit such scalability. So, yeah, so basically, there's one thing is when we want to have on-demand scalability, we truly want scalability in the compute side, okay, but not the storage side. The compute demand can change drastically over time, but the storage demand does not change very much over time. And compute is stateless, it's easy to autoscale. Well, storage is fundamentally difficult to autoscale. And in Share Nothing architecture, they always couple compute and storage into a single cluster. So that would make it very difficult to autoscale. Like if I scale, I have to scale compute and storage together, and storage is very difficult to scale, as we know. So it becomes very difficult. Therefore, when people say, okay, we want to have on-demand scalability for compute. So in the cloud, what should we do? Let's separate compute and storage. So that, okay, we know we don't need to autoscale storage too much. So now we can scale computation because it's separated as two services. I think that's it's not a limitation of Share Nothing, I would say, but it's more like it failed to exploit the new opportunity in the cloud. So in order to embrace this new opportunity, we need to go to disaggregated architecture.
Yeah, nice. I guess, yeah, like you say, it's nothing kind of against the sort of the design of shared office, because the rules of the game have sort of changed, right? And they've made it's made
Yes.
these new architectures possible. So let's talk about the sort of evolution of disaggregation and over the sort of since maybe like 2018, when you sort of had this sort of like great foresight of seeing this being a sort of a trend. So things sort of initially started off with separating storage and compute, right? And like systems like Snowflake and Aurora are sort of pioneers in that. But things have kind of started to go beyond that. So can you maybe take us on that journey from sort of day one, hey, we can split storage and compute because it's great because storage has got different characteristics to compute, and we can actually we can scale things differently just for compute, to sort of like where we are today.
So I think okay. I think a lot of cloud databases are separating compute and storage, and some databases are going further. I think there is consensus on separating compute and storage, and for the extra separation, extra disaggregation, like every system has a little bit of different exploration, right? So there's a very active area right now. At a super high level, it's basically like, well, for a subset of database functions, we can disaggregate that into a separate cluster. And there's so many database functionalities. So you can disaggregate in many, many different ways. So just to give you some example, for example, storage, okay, it can be further disaggregated. In Socrates, for example, from Microsoft, they further disaggregated storage into a login service, a page cache, and a durable page store. So if you think about the login service, for example, login service, the performance is really critical because it's on the critical path. But the log size is usually much smaller than the data, the page data. And because you care about performance and it's very small, you can afford using some more advanced technology, maybe more expensive storage to cut the latency there. But you don't want to use that expensive storage for the page store.
Yeah,
it's too expensive. But disaggregating these two, now you can use the expensive for the loggings, and that will improve the overall performance. So that's one example where, like, okay, because different functionalities have different performance requirements, by disaggregating them, now you can customize the implementation, right? So some other examples are, okay, we'll talk about storage, further disaggregation, and you can also disaggregate execution. Like, oh, we don't have to do all the execution in the compute layer. We can push some of the execution to, well, what I call a pushdown layer, a layer closer to the storage. It doesn't have to be within storage. It can be within storage, but it can be close to storage. Some other systems use, like Snowflake has this caching for intermediate data. They just say intermediate data doesn't, well, it has to be flushed from the compute node because it's too big. But you don't have to write it back to storage layer. You can write it back to this intermediate data caching layer that has lower costs than the storage layer like S3. Right? So some other examples like metadata layer query optimization as a service or memory disaggregation. So a lot of exploration, a lot of ideas floating around here.
Yeah, it's great. There's a lot of possibilities there. It's kind of almost, you kind of feel like a kid in a sweet shop, right? There's just so many different database functions. Like,
Yeah.
can we disaggregate this bit? Can we disaggregate that? But I guess
Right.
there is probably a tendency to want to do that. But I guess there is a limit to how far we can take that, right? So, because if we start jamming the network in between everything, eventually we're probably going to sort of lose all the benefits of the disaggregation, right? And I guess possibly in some scenario, I think you actually referenced this in your paper about this, that there is some situations where if you go too far with this, the traditional architecture, shared nothing, can actually be better.
Yeah. So that's actually a potential pitfall of disaggregation. It
Mm,
sounds like uh, it's not the case that disaggregation is always good. So
mm.
for example, you don't want to disaggregate everything.
Yeah.
Like I think it's like what the microservices are doing. Like
Yeah.
everything is a
Yeah.
separate service. So every application you have hundreds of services. You probably don't want so many services for databases. I mean, maybe, but I don't. I think that's probably pushing it too far. So disaggregation is this is a trade-off actually between performance and uh, like maybe separation of concerns. So the more you disaggregate, the performance tends to suffer. So if you want the best performance, you know what? Go share nothing.
Right.
That
Right.
will give you the best performance. So people wanted disaggregation not for performance, clearly. It's for elasticity, auto scaling, like this cost efficiency, on demand scalability, maybe separation of concerns. But you sacrifice performance in order to get
Yeah.
these features. So, so when design a system, I guess you should be very careful. If these elasticity or disaggregation is the property you really important for you, go for it. But be aware you're giving up some performance, and you probably can get some optimizations to get some performance back. But it's probably very hard to get all the way back to share nothing. So, but if for a particular use case, elasticity is not that important, well, maybe you don't want to disaggregate aggressively.
It's really interesting that because I mean, there's two sort of things sort of bouncing around my mind, and I know sort of when I was very much in research, you kind of I was at the time maybe you're very focused on performance, right? Because you want to make a throughput higher and latency lower, right? And that's how you get your paper accepted, sort of thing. And but when you start to set that against the actual business concerns and the actual people who run these systems in production, actually like, the things they care about, it's not just performance, right? There's many dimensions to this. And I think it's and this can sort of satisfy those goals and those desires for those customers. And I think it's interesting because you often see people say, "Oh yeah, disaggregation is the future," and that means that it's going to replace everything, and it's going to that's the in
No,
10 years' time that's what we're going to just be doing. Which, like you said, there, it's not true, right? Like there's both type of systems can coexist, and it all depends on what um the actual customer wants. So they want performance, go this way. You
yeah,
can care about more elasticity, you've got this. So it just actually increases the offerings for customers, I guess, and what's available. So I think that's really cool. Brilliant. So yeah, let's talk about, so obviously you and your team at the University of Wisconsin-Madison in the database group there, you've been exploring this design space and seeing what's possible within this paradigm. So let's switch some focus and talk about some of these projects that you've been working on. So you classify in your paper, you classify them into sort of three categories. So yeah, tell us about the stuff you've been doing to sort of reinvent or reimagine some core protocols in a disaggregated world.
yeah. I kind of classify the work we have been doing into three categories, but this is by no means exhaustive. I think other people have different dimensions of because there's huge design space, a lot of opportunities. So the three categories we did in our lab are the core protocols, like fundamental database, core database protocols, and query engine optimizations, and also some new capabilities that you can enable using disaggregation, like capabilities that didn't exist in traditional shared nothing architecture, for example. So I would just go through one by one. Um, so for the core protocol, like one work we did was to revisit two-phase commit. Like two-phase commit is this classic protocol. It's like very well designed. And I think originally it was assuming share nothing. So there was one problem with 2PC. If you're familiar with 2PC, you must know this. Like there is a blocking problem where in certain conditions, 2PC protocols can get stuck, and there's no progress. Well, at least for certain data pieces, they have to be locked indefinitely, cannot be released because the state of a particular transaction cannot be determined. And fundamentally, I will not talk about the protocol overall, but fundamentally, you have this blocking because some node has failed and the state on that node is not accessible. Because when the node fails, the compute and storage fail together.
Mm.
That's fundamental reason. The other nodes cannot see this failed node's disk, so you cannot make forward progress. But this is no longer true in disaggregated architecture because the storage is separate from compute. And you have to assume your storage doesn't fail because if your storage fails, you lose everything in your database. And so and their concern is not just about blocking anymore. Like you lose the whole database. So if your storage doesn't fail, and even if your compute fails, that's like other nodes, other compute nodes can still access to all the states in storage. So it's not, it can never be a case where a node fails, a compute node failed, and suddenly you lose access to your storage state and you cannot make forward progress. You can't see it. It's the other compute nodes, the log file is just sitting right there accessible. So by just leveraging that, you can address this blocking issue. Like, okay, the details is a little bit complicated. So I will not go through that, but that's the insight. Like it's the architectural change that change the fundamental assumptions that allow you to design protocols differently. We also did something for the control plane. Well, I probably talk about that briefly. The disaggregation work today, a lot of that mainly focus on the data plane. But the control plane, think of Zookeeper. That is mostly still this centralized service that is not disaggregated. So I think the work here is similar to like, oh, let's disaggregate Zookeeper so that it can also autoscale and it can also overlay on top of your database cluster, so you don't need to have a separate cluster. Yeah. So the second category of work we did is for query engines, and it's called pushdown processing. Nowadays, I think pushdown is adopted in many cloud databases, cloud production databases already. So it's like, oh, okay. Traditionally, in share nothing, every node is read from local disk, do some local computation, and then maybe some data exchange. So in disaggregation, you cannot read your local disk. The data will sit in the remote storage. So every time you read from a remote storage, you have to transfer data over the network. So it's actually much more data transfer over the network compared to a share nothing architecture. But that's definitely overhead. So one way to mitigate that is you actually push certain query processing down to the storage layer or close to the storage layer. So that means even if you only have 4 servers or a compute cluster, but when you push down the sort of operation like filter aggregation, you can leverage serverless pushdown layer, which may be able to use the hundreds of servers to process something in parallel and reduce the data and return to the compute layer. So that the data that received by the compute layer is much significantly reduced so that the performance can be improved. Right. So there are a lot of details about pushdown. We actually have a series of papers where you can push down simple operators. You can also push down a little bit advanced operators, like shuffle. Even shuffle can be partially pushed down. Like bitmap operators can be pushed down. And also, what about caching? How do you do hybrid push down and caching? Because intuitively, if you push down, it's very difficult to cache the result of push down computation. Because that can be arbitrary predicate. Like how can you leverage that? So there are some questions like how do you do hybrid pushdown and caching to get the benefit of both worlds? And also, what if the pushdown layer is saturated? So you want to push down something, but other people have already pushed down a lot of computation. So if you push down further, it will actually be slower than not pushing
worse,
down.
Yeah.
Yeah, because the pushdown maybe computational power is not that powerful. So what do you do in that case? Like our solution is to push back. So you push down, but the pushdown layer says, I don't have CPU power sorry. So just return that to the compute layer. So you can just, okay, now I just load the original data from storage. So I can do some of those designs to get overall better performance. Yeah. So the third category of work is to enable new capabilities using disaggregation. And the project here is it's called Hermes. It's a real-time. We want to achieve real-time analytics, and like a lot of people have been working on this topic. And one solution is to use a hybrid transactional analytical database like HTAP. But that requires to migrate to a new database. Like I've been using Postgres and maybe an analytical database. I don't know, Presto, happily. Now, because I want a real-time analytics, you ask me to migrate to a new database. That can be a little painful.
Yeah, people don't like doing that,
So
right? They like to stay on their databases if possible. Yeah.
exactly. And if you
Yeah.
migrate to a new database, you may lose features. And maybe
Very
what
true.
you could do before, you cannot do now. So there are more headaches. And we were thinking, well, can we leverage disaggregation? Well, we'll just introduce a new module that can help you achieve real-time analytics. And basically, it's a layer sitting. Okay, both AP and TP we assume is disaggregated, so the storage is remote, and we insert a new layer in between. Okay, so we capture the transactional log, and we take that log tail and merge that with the analytical read, right? So that we can achieve real-time analytics using existing engines. And don't need to modify these engines, and also we can get pretty good freshness. So that's we call it off-the-shelf real-time analytics because you don't have to switch your database.
Yeah, I like it. I mean, that solves that problem of usability, right? And like you're saying, the operational concerns of having to migrate data around between systems, which is kind of people don't like
Exactly.
doing. So yeah. Actually, when I was looking through the sort of the projects you've been working on, and obviously I really like the 2PC one because I mean I think it's my favorite algorithm 2PC because it's just like, I mean, it's obviously it's got its problems, but it's a really nice, easy to understand algorithm. That was a really nice sort of take on it, I guess, and sort of modernizing it in a way. So
Thanks.
that was definitely one of my favorites. But I really like the Hermes stuff as well, and sort of kind of it feels like because a lot of people have tried to do HTAP right over the years, and nothing's ever really stuck. Right, no one's ever really solved it. From my opinion, and things I've come across, like in a brilliant, nice way. And this kind of I feel is definitely getting close to that sort of like the best we can do with HTAP. So I really did like that as well.
Yeah,
Cool.
yeah, I think it has potential.
Yeah, definitely for sure. I mean, I kind of I'm kind of going off piece here a little bit, but do you have any sort of plans to sort of take these research prototypes into a more production environment, or sort of get them out in the wild and get people using them, or is the plan very much to keep these things research projects for the time being?
And that's a great question. And that's the question I asked myself many times in the past several years. I really hope to get something out there so people can use. That's kind of like for system researchers, that's always the dream.
Yeah,
Right? You want people to use your system. I think I tried that actually. But there is a challenge for cloud databases. It's about cloud, and it has to be big scale. So
yeah,
anything about cloud database, you want it to be practical, it's probably going to be something pretty big, especially we're talking about infrastructure level.
yeah,
So at this point, it seems to me um, maybe, okay, it's hard for us to build something ourselves, but we can put the idea out there. We can try to prove it using some prototype. But maybe it's easier if, okay, it's a big company or someone else, a startup, I don't know. They want to pick up this idea and they want to incorporate some of the part of it or the entire idea into their system. And that's probably an easier path. Um, yeah, because the sheer scale of these systems is a little challenging to do that in the lab.
yeah. That's very true. You sort of need a whole engineering department, right? Which is not something you kind of have on hand, right? When you're working in academia,
Exactly.
right? It's cool. Yeah. So I guess kind of following on from the thing we just chatted about there is that speaking about practical implications and things. If I was a company now, sort of designing a system from scratch, or maybe taking an existing system and trying to migrate that to a more cloud native system, what would your advice be? And what would you be sort of saying the most common mistakes to try and avoid in these people trying to adopt disaggregation?
I think there have been several quite successful formulas out there, like commercial systems doing a disaggregation. Many of these systems do disaggregation in similar ways. I think one potential mistake, I kind of mentioned this earlier, is over disaggregation. Like before you're certain that a particular disaggregation will give you benefits, be a little careful before you decide to disaggregate that particular component. Because the more you disaggregate, it tends to be that you suffer more of the performance issue. So be careful with what you want to disaggregate. Otherwise, I think, if you just disaggregate compute and storage, it seems pretty natural. Like has been a lot of successful stories. But if you want to go further, just be careful.
Okay.
Disaggregating everything may not be a good idea.
Yeah, in that stage of age, the separation of storage and compute seems a pretty tested formula now, right? That's
Yes.
definitely pretty safe, I think. But yeah, that's cool. So yeah, let's switch our focus then and talk about the future then. So for researchers and system implementers, what do you think? Obviously, we've got sort of a smorgasbord of possibilities, and there's so many things we can disaggregate. But yeah, what do you think are the most exciting open problems in this space?
I think, as I said, there's just a lot of opportunities. You think about it, since like how often do you see a new architecture for a distributed database? That doesn't happen not very often, right?
Yeah, that's very
Maybe
true.
every decade, every few decades, you see such opportunity. And now it's like this is a great opportunity. And also, there's a lot of richness in this design. Like you can disaggregate a lot of things, and of course, disaggregating everything is not a good idea. So you can try. Okay, what makes sense to be disaggregated in what context, maybe for just certain workloads. Um, and if you disaggregate a lot, then performance may suffer. But can you come up with some mechanism or algorithm so that it can get most of the performance back? Like make the network not a key bottleneck, for example. Right. So we have been thinking about some modules, for example, indexing. Uh, we haven't seen a lot of work disaggregating indexing. Or again, there's cross control. The query optimizer. You can disaggregate query optimizer. You can disaggregate materialized views. It's like caching, but more advanced caching. Because these disaggregated services can be shared by many database instances, so you can get some common knowledge, like query optimizer. Like maybe different databases that have different knowledge about query optimizer. If you put it together, it can make a better decision, right? So there are a lot of opportunities. Like we are exploring a subset of these things as well in our lab, but I just feel there's just a huge space with a lot of opportunities. Another thing I think is pretty interesting is we haven't been talking about a single cloud so far. Okay, everything in a single cloud. That's great, but there is also a need to go to multiple clouds, right? And then not necessarily multiple public clouds. It can be I have a private cloud with some of my maybe privacy sensitive data, and also I store a lot of data in S3. And now I want to run a query between these two sets of data. How can I do that? Right. So there's like even bigger design space. It's not a simple disaggregation architecture. It's not like storage is one layer, compute is another layer. It's like maybe multi-disaggregated architecture that you have locally have maybe disaggregated, and in the cloud it's also disaggregated. And now you want to run query, it's like, oh, where do I run which part of the query? And how much computation I need, I can even allocate that elastically. So I think that's also a fascinating problem space. It's even bigger design space, and I think there's definitely a need for such a system, um, and a lot of optimization opportunities. Like if you do the query in a certain way, it's probably going to be 10 times more cost efficient than the other way, and in a naive way, for example.
Cool. Yeah. Another thing I mean, it's amazing. We've gone through a podcast so far without mentioning AI because it's everywhere, right? And it's hard to kind of
Yes.
get rid of it, but and avoid it these days. It's in yeah, it's everywhere. But there's the way I want to kind of approach this question is there is a hell of a lot of investment in that sort of space, right? Which isn't necessarily directly related to databases. Obviously, it sort of gets caught up in in the things that kind of, how to phrase this question. People aren't directly talking about databases, but like databases are still part of the ecosystem is probably how I would phrase it. But because there's such a huge investment in it and the kind of that the things are being developed all the time, what do you think are the implications of that, or the sort of the side effects or the knock-on effects that it might have on the cloud environment that might change what's possible with disaggregation and databases, or what directly might impact databases in the sense of like the functionality that we need to add and how that might play into disaggregation as well? Sorry if that's a bit of a long-winded question.
And that's a great question. Um, I need to be careful here because I don't know too much about the AI part of this space. Um, I think, okay, the way I think about it is there is this mechanism part of the system and there is this policy part of the system. AI is really great at the policy part. Like for example, we say disaggregate. Okay, great. Let's separate it. We make the decision. But then you say, oh, you can auto scale. Awesome. But how many servers you want at a given time? And how do you want to scale it? When do you want to scale it? Like AI is great for that, right? Okay. Another way to look at this is like, okay, we enable auto scaling. Perfect. But how do you maximize the benefit from auto scaling? I think you cannot let human make a decision all the time. I think okay, their AI is can play a very critical role because that's their domain. So I think that's part of it. Like you have a lot of parameters you can tune, like AI can help you tune those parameters. And I think AI will database will going to be a very important component in overall systems, right? Including AI, like another component. So I think there got to be a lot of interesting trends. I don't know exactly what will happen though. I think maybe in the future most of the queries will be generated by AI,
Mm.
but I don't know what that means because like maybe AI they will access the database in one way today, but next like 2 days later it completely changes its model. I mean that can happen. So I think it's a little hard to predict exactly what will happen, but exciting things will happen. That is for sure.
Yeah, that's very true. We can agree on that for sure. Cool. Yeah, kind of keeping on the theme of the future. If we were to sort of have this conversation again in 10 years' time, what impact do you think disaggregation will have had on the databases and the database community?
I think well, it's probably just like what Share Nothing had, the impact Share Nothing had like maybe 30 years ago. I hope disaggregation, well, it's probably already happening. Like all cloud databases are kind of adopting disaggregation today, and I think it will go deeper, disaggregate even more, um, and the system will become more composable, more modular. Like modular disaggregation is kind of similar concept. Disaggregation is on the physical level, like physically separated clusters, and composability is more about well, it can be logical or physical modules, like software modules. So I think these two concepts will go hand in hand. So system will become more composable as well. Like you can say now I want to build a database, but I don't have to build everything from scratch. I can reuse this query optimizer, which is probably a service provided by someone else, and I can use the storage, um, and I can just build my engine. Even building the engine can use something like Arrow for the internal data structure. So I think that will be uh, like it's much easier to customize and build database systems. Um, and I think maybe the biggest impact is just this become common sense. Hopefully, one day this become common sense. People would not even ask, "Oh, are you using disaggregation or not?" Like, "Oh, isn't that the only way to build systems?" Or like for build
Yeah.
large scale cloud database systems. So I think if it becomes common sense and people don't even realize this is the concept, and I think that's probably the biggest success.
Yeah, definitely. It was really interesting there what you're saying about the almost having this ability where you've got all these services, you can almost like pick and mix and build your own database, and you can even imagine that happening almost somewhat on demand. Basically, a query comes in and there's some sort of optimizer, I don't know, like
yeah,
some magic AI, and it builds your database on the fly and uses the logging service from there, the query optimizer from there, because of the type of query it's wants to ask. So yeah, the possibilities really are sort of endless and quite. I'm sure the next 10 years, I think, are going to be very interesting as well. So yeah, cool. Let's do a bit of like have a reflection now, because I know you've worked with some very, very influential people in databases over your career so far. There's some big names in there, like Michael Stonebreaker, for example. So how would you say those relationships have shaped your approach to what first research and then second system building? I know those two things aren't mutually exclusive, but yeah, how have they shaped your approach to those?
yeah. So yeah, I've worked with a lot of great people, and I learn a lot from them. To the extent sometimes I don't remember which part what I learned from individuals. Just
Yeah.
a lot of them tell me things as like shaped my research taste. I think maybe there are two things I want to say. One is um, I think one thing I learned earlier in my career was try to do research that is demand driven. At some point in my career, I was like, okay, I want to work on really cool ideas. So
Mm,
it's more like intellectually interesting, but I didn't really think about, oh, but who needs it?
yeah. Yeah.
Then I try to change the mindset, like based on what they told me. And maybe it should be demand driven. Like let's understand, what do people need? And maybe sometimes they understand they are needing this, they will tell you. Sometimes they don't know they need this, but they actually need it. So you at first understand what people actually needs, and you probably need to observe some trends in industry, like what's going on. We'll talk to engineers, like what are working on, and they will tell you engineering challenges, which may not be research challenges. So you need to extract the research question out of these engineering challenges. So it's probably actually a research challenge. They may not even realize it. Okay, and for example, disaggregation is kind of the kind of idea that way. So you get a research question, you abstract it and say, okay, this is the research question, how you define it, and then you develop solutions for the research question. Then the solution will also be hopefully useful for the real problems that people are facing in industry, because it's based on the demand there. It's demand driven. Um, Another approach is, which is kind of similar to this approach, is like I try to follow the trend.
Okay.
Um, so the trend may not be demand. It may be, okay. You can say AI is a trend because a lot of people are doing research there. Um, what I mean, the trend is not what the papers are about, what the researchers are working on. It's more about what's happening in industry. Like
Mm,
clearly, you'll see something is going to be the future. Um, and for example, back then, I clearly thought, okay, cloud is the future, and cloud database is going to be the future. And that if that happens, we can innovate one way or another. There's just a lot of problems waiting for you to work on. But you just, if you believe this is the trend, you jump on it, and then 10 years later, there'll be the infinite problems for you to work on,
yeah.
and the potential impact also be big. Some other trend I'm following right now is like and we're not talking about this today, but like GPU databases is another trend we are betting on, because GPU seems to be have like a great trajectory going forward. So yeah, so I think those are maybe two um, general approaches to research.
Yeah, nice. So I've been demand driven, which I think, yeah, exactly. Like, there's no point in creating anything if someone's not going to use it, right? You want to solve someone's problem, right? That's the way to sort of be successful in anything, right? In business, in whatever. Like, if you can solve someone's problem and it also satisfies some demand, then great, right? You're onto a winner. And same
Right.
with the trend driven, right? Like, yeah, I guess it is sort of sometimes hard to get the signal from the noise, especially with stuff like AI. But if you can kind of peel back that noise and sort of look at the structural trends and sort of jump on one of those, then yeah, you again, it's a good way to sort of set yourself up for success, right, longer term. So yeah, definitely agree with those. Very those insights. Great. So we've kind of arrived at the end of the podcast now, and we're on to the last word. So two things here. There's first of all, what would you like practitioners to have taken away from this podcast today? And secondly, what would you like researchers to have taken away from our chat today?
I guess I'm probably have the same message for both
Yeah.
a group of people. I think disaggregation architecture is the new architecture. For decades is finally we have a fundamentally new architecture. And if it satisfies your need, like scalability, elasticity, this is the way to go, and it opens a vast design space. But this is maybe more for researchers. This vast design space, but it's not. It's largely unexplored. Like we are still in the early stage. Like look at how many papers are about disaggregated database versus share nothing database. It's like the design is way more complex, but there's so much fewer papers on it. So we just don't fully understand it. Right? There's a lot of research that can be done and a lot of potential impact that can be made in this topic.
Yeah, fantastic. That's a great message to end on. So yeah, thank you so much. It's been a lovely chat today. And also, before we do finish, we should give a shout out to, we've had 2 of your students on the podcast before. So we had Yifi who came on, and it was episode number, if I'm remembering this correctly, I did write this down, so I didn't
2
forget.
years ago.
Yeah, 2 years ago, episode 48. And yeah, if you're interested in how you can optimize joint performance, go check that episode out. And we also had Abigail came on recently. She was in our season 2 of our DuckDB and research series, which is episode 2 in season 2. Sorry, I should say. And that was all about DBMS extensibility, and she was causing anarchy in databases. So yeah, do go. It's a great episode. So do go check that out as well. Yeah. Thank you so much. It's been a lovely talk today. And yeah, where can we find you on social media or anything like that? Where do you tweet at, or it's not tweeting anymore, right? It's just Xing, I guess, or any of those. Yeah.
Yeah, I'm not super active on social media, but I have my personal website. Just search my name, I think. Yeah, and I do use X a little bit, but not too much.
Cool. Well, we'll end things there. Thank you so much, Xiangyao. It's been a really, really insightful
Thank
chat
you,
today.
Jack.
And yeah, great. And we'll see you all next time for some more awesome computer science research.